Today, I want to reflect on a significant incident in space exploration, the Mars Climate Orbiter mishap. This incident teaches us valuable lessons about precision, communication, and the crucial role of technologies in space missions.
So,
For the summary of
the
this
summary
report,
report, the report
so
of the
the paper
summary is
highlights a
investigating the
proactive
disappearance
approach
and
to
eventual
prevent
crash
such failures in future
of the
missions.
Mars Climate
In light of
Orbiter
the findings,
spacecraft
it emphasizes the need
after
of
its
meticulous
launch
unit
in
consistency
1998.
to be established and
This is the
maintained
focus of
over the
this extensive
course
report.
of the mission
So, the
lifetime and
study is
calls
on
for
phase 1,
increased
which
awareness of
identified
the
the
possible
accident's
hazards
primary
connected
cause.
with unit
The crucial
conversions.
problem was found to
Space
be
agencies
an
may greatly lower the danger of crucial
inaccuracy in
errors
the
in
unit
unit
conversion
conversion and
between metric
guarantee the
and
success
imperial
and
units.
safety of upcoming
That's
space
the
missions.
two
By
software use
putting
of the
strict
NASA.
cross-compatibility assessment into
The
space
spacecraft was
and
unable to
encouraging the
enter Martian orbit
precision-driven
due to
culture in the
a
unit
sequence of
conversions. So this
miscalculations
extensive report
caused
looks
by this
into the
error.
investigation into
In
the
order to prevent
1998
such mistakes in the
disappearance and
future, the paper
eventual
emphasizes the
crash
value of
of the Mars
stringent
Climate Orbiter,
cross-system compatibility
with a
assessments and highlights
particular
the
emphasis
significance of
on
careful unit
Phase 1
consistency in space
and
missions.
the goal of identifying the accident's fundamental cause or the main cause of the accident. So, the study's most important finding is that several software systems or inaccurate unit conversions between metric and imperial units. This mistake caused a number of calculations to go wrong, which prevented the spacecraft from entering Martian orbit. Acknowledging the seriousness of this error, the paper emphasizes how crucial it is to carry out thorough cross-systems compatibility analysis in order to avoid such inconsistencies in future space missions. The event is a sobering reminder of how important it is for space exploration projects to pay close attention to unit uniformity. So, what are the issues of this event? So, due to a unit conversion issue, the spacecraft had trajectory errors. So, what are the issues of this incident? So, a crucial unit conversion problem caused the disastrous trajectory mistakes that resulted in an inhabitable or unsurvivable altitude on Mars because of discrepancy between Newton seconds used in the spacecraft software and the pound seconds used in the ground software. So the spacecraft's trajectory was altered, causing the deviation of its route. So the ground software's use of English units pounds per second per thruster performance data instead of the designated metric units Newton per seconds caused the disastrous deviation, a number of identified contributing factors. So, lack of familiarity with the navigation team, missed trajectory correction maneuvers. So, poor system engineering and communication, inadequate staffing and training for the navigation team, and insufficient verification and validation of ground software all contributed to the situation's exacerbation. Disconnected elements culminated in an unfavorable conclusion for the spacecraft's mission. So, complete actions are necessary to resolve and stop such serious mistakes in the future. This entails careful software testing and validation, the consistent application of standardized unit, improved engineering communication and teamwork, and sufficient staffing and training for navigation. Space organization can work to assure the success and safety of upcoming spacecraft missions by taking measures and learning from these contributing elements. So, those are the response of NASA. So, another is NASA took immediate corrective measures in the aftermath of the Mars Climate Orbiter spacecraft disaster to ensure that such occurrences would not happen again. They standardizing the International System of Units or SI for all projects was a crucial step. By removing the possibility of unit conversion errors, the standardization attempted to solve a critical element that lead to the mission's failure. NASA placed a strong emphasis on enhanced communication and collaboration amongst engineering teams in order to reduce oversights and break down knowledge silos in the spacecraft development process. And furthermore, NASA strengthened the software development process, verification and validation processes. The purpose of this step was to improve the overall dependability and quality of spacecraft systems. So the space agency tried to find and fix possible problems um, before they before they may jeopardize mission success by implementing tighter inspection and testing procedures. And additionally, NASA increased staffing levels and gave teams participating in upcoming missions more training since it understood how important navigation teams were to maintaining accurate spacecraft trajectories. These steps were essential to bolstering the expertise and readiness of those responsible for spacecraft navigation and control. And in conclusion, NASA's response to the Mars Climate Orbiter event involved a multi-pronged strategy that tackled the organizational and technical facets of spacecraft missions. NASA wanted to dramatically increase the stability, coherence, and overall performance of future spacecraft missions. To this end, the agency invested in the training and staffing of navigation teams, standardized units, improved communication and collaboration, and implemented strict verification procedures. So, importance of digital signal processing and communication. So, expanding on the role of digital signal processing or DSP in communication in spacecraft exploration, these technologies play a pivotal role in overcoming the challenges posed by the space environment. DSP makes sure that the signals sent between the spaceship and Earth are of the highest quality, which is important in the expanse of space where dependable communication is essential. It reduces noise and it improves signal clarity, making it impossible to collect important scientific data from the spacecraft's instruments. Furthermore, digital signal processing is equipped communication systems become tough and adaptive in the dynamic, constantly changing environment of space by identifying and fixing any transmission problems. They are able to optimize the usage of available bandwidth. So DSP's capacity to process between the spacecraft and Earth, this becomes more essential for controlling telemetry, telecommand, and remote operations, greatly enhancing the overall performance and success of spacecraft missions. So DSP and communications are essentially the fundamental elements of technology that ensure accurate data processing and efficient mission control in the tactical and uncertain field of space exploration. Their integration guarantees accurate and efficient navigation, communication, and data transmission by spacecraft, which eventually results in successful and major missions beyond Earth. So, what are my takeaways as a future computer engineer? So, the incident with the Mars Climate Orbiter highlights how crucial or careful attention to detail. It emphasizes how important it is for engineers to double and triple check every part of their work because even small mistakes can have a disastrous results. standardized terminology, and unambiguous guidelines, and reducing the possibility of miscommunication. And furthermore, coordination is essential. Interdisciplinary collaboration is necessary for space missions, just like it is for any successful team effort. Engineers need to collaborate easily and understand the importance of their individual roles in the larger structure. Comprehensive testing protocols also act as a safety precaution, similar to playing with a toy only after it has been tested. Thorough testing serves as a preventative measures, identifying and fixing problems prior to a spacecraft and departing on its mission, as well as ensuring the stability and dependability of vital software systems used in launching and navigating the spacecraft. So, refinement of techniques and safer, more successful space exploration efforts are further guided by engineers, learning from past mistakes like the Mars Climate Orbiter event. So, that's all. Thank you for listening and have a great day. Bye bye.